In chapter 5, we introduced the concept of a sample mean, right? Finding the distribution of the sample mean. I didn't really explain why we were doing that, but now you know, because we're using that for all of our confidence intervals and our hypothesis tests, and all that good stuff, right? So now you know why we are finding this, right? So for a random variable x with mean variance, or sorry, mean mu, if the variance is known, then we know that our sample mean follows a normal distribution with mean mu and and standard deviation sigma over square root of n, right? Because this is the standard deviation of our sigma, or our sample mean. I cannot talk, I'm sorry. Right, so the central limit theorem gives us that this is also true for unknown variance when the samples are very large, right? For n greater than 30 or 40 or so. This is how this applies to our population, even if we don't know our variance. If we don't know our variance and we have a small sample, we estimate our sample variance, and then we have our standardized sample mean, essentially, is this t, and it follows the student t distribution with n-1 degrees of freedom, right? With n being the sample size. I don't think I say that anywhere, but in general, n is the sample size. Right, so our t is there, and it gives us this guy. All right, so let's pop back. Sorry, I keep going back and forth. I thought this would be a good idea. Not sure about it. All right, so if we have our normal distribution with a mean of 222 and standard deviation of 2.2, and our n is 22. Oh, I thought it was funny when I made this up. Sorry, I forgot about this. All right, and so we have all these guys, and we want to know what the probability is that the sample mean, right, our x bar, for a random sample of size 22, what is the probability that that sample mean is between 202 and 232? Right? So what do we know? We know that our x bar follows a normal with mean mu, and, or I can actually go ahead and, or here, mu and standard deviation 2.2 divided by the square root of n, right? So our x, probability of sample mean is between 202 and 232, is going to be probability, because we had p norm, and we are estimating that with our mean 222, right? And our 2.2 divided by the square root of n. So 232. $202. Oh, apparently I made my thing so wide, it's very sure it's going to be in there. But this is what happens when you make up examples on the fly. So what is the probability it's going to be between 224, 221? There we go. Man, that was a tiny standard error, I suppose. All right, but in general, we have our sample distributions for our sample mean, We know what those are. We know when we need to use which one, right? Which one we want for what time. Okay, awesome. And we can find those estimates, right? So T is kind of similar, except you need to put in your estimates into this guy.